Quadratic functions in vertex form. Getting ready for vertex form versus standard form. Before we can work on standard form and vertex form, we have to understand a few algebra concepts beforehand. So we need to remember how to combine like terms, so add and subtract them. The first thing we need to do is collect like terms, and then we add or subtract the coefficients of the like terms. The next thing we need to know and remember is our distributive property. So when we have A times B plus C, A has to be multiplied with the answer to B plus C. And the easy way to do that is to multiply A with B and to multiply A with C. This is known as the distributive property. So to expand and simplify the following expressions, I have negative 2 times all of x plus 4. So the negative 2 gets multiplied with the x and also with the positive 4. Now, I can rewrite it that way. So I can see the negative 2 times x, subtract 2 times positive 4. Or I could have gone immediately to the answer of negative 2x, subtract 8. Okay, remembering that a negative times a positive is always a negative. Negative 2 times 3x plus 4y, again, the same thing, negative 2 times 3x, and also negative 2 times positive 4y. Again, I can write that step out if it makes it easier for me to remember. A negative 2 times positive 3x is negative 6x. Negative 2 times positive 4y is negative 8y. I don't have to do that first step right here. This step here is optional. Depends on how your brain works and which way is easier for you to do your answer. Hopefully, by the end of this unit, we'll all be writing it just in that final answer. X plus 4 times x minus 5. That's a little bit different than what we've done so far, but it still involves the distributive property. So it's kind of like pretending this 4 is not here, and we do x times x minus 5. And if the x wasn't there, we would just do 4 times x minus 5. Look at that. We would multiply the x with the x and also with the minus 5. And we need to do the 4 with the x and the 4 with the negative 5. So I could start out by writing it as two separate distributive property questions. So I'm doing x times x and x times negative 5, just like what I drew up here with the red arrows. Or 4 times x and 4 times negative 5. And again, I can split it up like I did, but it's getting kind of cluttered, so I probably want to avoid doing this line as I move forward. So x times x times negative 5 right here. 4 times x is the next thing, and 4 times negative 5 is the last term. X times x is x squared minus 5x plus 4x minus 20. And you'll see right here, we have two like terms. So if I have 5 negative x's and 4 positive x's, I've got one more negative x to give us x squared minus x minus 20. X minus 3 squared. Wow, that's a little bit different than what we've seen. We have to ask ourselves, what does x minus 3 squared mean? Well, it means x minus 3 times x minus 3. Now I'm back to the same distributive property question I had on the screen before, where I do x times x and x times negative 3. And I would also do, negative 3 times x and negative 3 times negative 3, which you'll see is what's written on the next line. And again, distribute x times x times negative 3, negative 3 times x, and negative 3 times negative 3. And if I simplify, I've got x squared, positive times negative will give me negative 3x, negative 3 times x, negative times positive is also negative 3x, and then I have negative 3 times negative 3, which leaves me positive 9. And again, to combine my like terms, I've got a negative 3x and a negative 3x to give me negative 6x. Negative 3 times x plus 2 squared. Okay, we've gone outside our box again, and we do have to remember our order of operations because that is important. Okay, I have to do my exponents first, so I'm going to leave that negative 3 alone. And I'm going to strictly work with my exponents. Now again, I have to ask myself, what does this mean? Because I can't evaluate x plus 2 squared quickly yet. It means x plus 2 times x plus 2. But keeping in mind this was an exponent, I'm going to work with it first. So x times x and x times 2. And I need 2 times x and 2 times 4. Or, again, I could have split it up into that extra distributive property step where I showed the x times the x plus 2 in brackets and the 2 times x plus 2. But you'll notice something really important here. I've got an extra set of brackets right here and here because the answer that's in those brackets needs to all be multiplied by the negative 3 that's in front once we've completely evaluated our exponent. Again, I can do the same distributive property here, x times x, x times 2, 2 times x, 2 times 2, and I simplify. Again, I still have my extra brackets here and my negative 3 out in front. So I've got negative 3, my extra bracket, x squared plus 2x plus 2x plus 4. Again, my extra bracket's still there. And I have to add my like terms. And when I scroll down, again, I still have my extra set of brackets. And every term in there now has to have the distributive property used on it because this negative 3 is being distributed to all 3 terms in this trinomial. So we end up with negative 3x squared minus 12x minus 12. And I bet by now you're wondering, why do you care? Because we've been talking about quadratics, and this looks a little bit like algebra. So we need to know what quadratic functions are. Quadratic functions are any function that can be expressed in any one of these 3 forms. You have standard form, where f at x is ax squared plus bx plus c. Vertex form, f at x is a times all of x minus h all squared plus k. And factored form, f at x equals a times all of x minus r, and then multiplied by all of x minus s. Now, we're going to be working this semester to change vertex form, to standard form, which we should be able to do after what we just finished, to change standard form to vertex form, standard form to factored form, and so on. We want to be able to mix it up and move between all 3 forms of a quadratic in the end, because all of them have different purposes and give us different information. So what I'd like you to do is just get a piece of paper out and quickly write down the words true and false to answer the following questions. You can use standard form to determine if a quadratic function opens up or down. You can use vertex form to determine if a quadratic function opens up or down. You can use standard form to determine the coordinates. You can use vertex form to determine the coordinates of the vertex. You can use standard form to determine if a quadratic function has a vertical shift. You can use vertex form to determine if a quadratic function has a vertical shift. You can use standard form to determine if a quadratic function has a horizontal shift. You can use vertex form to determine if a quadratic function has a horizontal shift. Standard form and vertex form always look different. Before you come to class tomorrow, you need to complete exercise 4, page 11, number 1, and there are a few quadratic functions here that I would like you to expand and simplify so that they are written in standard form. Thanks.